Welcome to a Decepticon and Autobot walk into a bar. This is a new Python tool for enhanced OPSEC. I'm Joe Gray, coming to you from almost on the other side of the world. I'm here in the United States. So this is going to be a project that I took on to enhance my own comprehension and understanding of both Python, artificial intelligence to a degree, machine learning, and natural language processing. I wrapped it all up in a way that will allow a positive outcome to occur. So I'm going to go ahead and kill my camera now, since I've been told that I have a face made for radio. That continuing, about me by day, I'm a senior OSINT specialist complex. I have some experience with Python scripting. I'm incredibly interested in the data sciences. As I stated previously, I do frequently compete in the Trace Labs OSINT Search Party or Missing Person CTF, whichever you know it by. My team, the Password Inspection Agency, actually just won the last competition that occurred as part of DEF CON. With that, with a lot of what I do regarding OSINT, I look at the yin to the yang of OSINT, which would be OPSEC. I also have advisory volunteer roles with both the National Child Protection Task Force and Operation Safe Escape. Operation Safe Escape being in bold because, honestly, that's the organization that benefits most from Decepticon. A few things that I'm not a programmer or a developer in nature. I'm by far not a mathematician or a data scientist, nor am I an expert when talking about things dealing with trafficking or domestic violence. It's something that I'm concerned with. It's something that I definitely have interest in making a positive outcome, but I'm by no stretch of the imagination an expert. So before we get started, I have a few definitions for us to go over, just so that we can level the playing field with everything that'll be talked about in this presentation. First, we have OSINT, open source intelligence. That's basically information gathered from public sources in an intelligence context. We have OPSEC, operation security. Basically, that's taking steps to obscure, hide, or masquerade information about you and what you are doing so that adversaries or other concerned parties will have trouble finding you or making any determinations in terms of the reliability of the data. I'm a huge fan of implementing disinformation and deception through that. In fact, implementing disinformation and deception to enhance your OPSEC is a term I've been calling that Decepticon for the last couple of years, hence the name of the bot. Machine learning, that's just the study of math and algorithms to improve the automation via learning, if you will, so that it assists us in developing algorithms to be able to learn, if you will, based on the outcome of the data. We can also do predictions and decisions based on that. With Decepticon, it's mostly focusing on predictions. Data science is an amalgam of several disciplines that seeks to study the relationship between data structures and the processes and algorithms to help us gain insight from the data. I like to think of it from the perspective of data science seeks to identify patterns that are not visible to the human eye or the human mind. We have artificial intelligence. Yes, I will admit that's a term that has been kind of ruined by vendors as of late, but it's the study of intelligence shown by machines and programs to attempt to mimic that natural intelligence. Natural intelligence being the intelligence shown by humans or animals. And then finally, we've got GPU. That's the graphics processing unit. It's a specialized system on board many computers. In fact, any computer that has any sort of graphics has one. But in this scenario, we're using it to accelerate the processing of images or video. More specifically, it's used within machine learning to speed up processing. NVIDIA has some really cool toys for that. So the problem, one of the leading ways that adversaries find their way into the lives or back into their lives of their victims is social media. So what is an adversary? That could be a malicious person seeking financial gain. That could be someone just seeking to harm someone else. Abusers, traffickers, political opponents will do that. In the United States, we've got the possible apocalypse coming up on the first Tuesday in November with the election. I really hate to toss the term nation state out, but depending on the person's threat profile, a nation state could legitimately be an adversary for them. And then you also have what I call adversaries of opportunity. And that would be in the case where someone has really bad OPSEC and the adversary is just out there looking and just happens to come across that particular person and notices, hey, this account is hemorrhaging information. Let's exploit it and see what we can get from it. So when we talk about victims that could be public figures such as politicians or executives, obviously there are some companies out there whose executives are universally a target because of what the company does or who the company does business with. And then we have victims of domestic abuse and or trafficking. Many times they don't have much say-so in the matter whatsoever. And then we also have people with poor or misguided OPSEC. For example, I was debating with a friend from when I was in the Navy on Facebook a while back about privacy. And he's like, oh, I don't have to worry about this. I use a VPN. And I was like, oh, cool. Which one? And he's like, oh, it's a free one. It's this. And I don't recall what it was exactly, but I pointed out that with a VPN, especially, that's one of the products that you definitely want to pay for because you have some expectation of support. That's not to say that your data won't get sold, but you have a more legitimate claim when it comes to that. And oftentimes, if you don't pay for the product, you are the product. References for that, see Facebook and Google. Thankfully, for many of you, you're subjected to GDPR, so you have a certain level of privacy and protection that I only wish I had. And to be honest, had COVID not happened and I had actually traveled to Gdynia for the conference, I was going to hop on to some Wi-Fi connections around the area and use the right to be forgotten, because what I've learned is many platforms, when you go to opt out of things, they don't do any validation checking to verify you're a citizen of the European Union. They just look at the IP address. Oh, well, this is coming from the EU. So kind of bummed about that. But life goes on, and there's always next year, and if not next year, the year after. And eventually it will become safe for us to all travel again. So after I rebutted that to my friend, he was like, well, I used this DNS service as well. And I hadn't heard of it, but I looked it up and it looked pretty solid. And I explained, okay, well, you still need to implement things like HTTPS. If you're doing certain things, you might want to use Tor. You may want to do this. You may want to do that. And it turned into a really good private conversation between my friend and I. And he learned a lot, and I learned quite a bit myself. So as we dissect some advice from an OPSEC perspective, if someone's being harassed or stalked, some of the advice I've seen tossed around is, well, just abandon the account. Well, that's not always feasible, to be honest. And with that being said, it could cue the adversary that the account has been abandoned. It could also lead them to go looking for alternative accounts. And if someone's using accounts that doesn't have the person's real name on it, especially with Facebook, I don't know if this is something that you encounter in Europe, but in the United States, if you create a Facebook account and they don't believe you're using your real name, they will prompt you for a driver's license. And if you don't want to provide that, they just straight up shut the account down. So if someone's trying to evade an adversary and creates an account under a fake name, a fictitious name, then that person could report the account. If they report it enough, then that account will be prompted for submitting some form of identification. And when they fail to do so, the account gets burned. Let's face it, some people have to use social media for work. Me working in the OSINT field, I have to use social media for work. That also being said, I don't have to use legitimate accounts, whereas some people have to use legitimate accounts, either to interact with customers or to run a business page or something to that effect. And I mean, I'm just going to be real here. Why should a victim live in fear because someone cannot respect their wishes and their privacy? And at the same time, some victims just are not aware of the adversary until it's too late. So continuing to dissect this, if the abuser wants to continue trauma, they can create fake accounts of their own. They may leverage friends or friends of friends that may have access to see the victim's posts. As I stated before, they may report those alternative accounts for being fake. There was a case just about a week or two ago. There was a young man, a college student in India, who published a Medium article talking about how he had a crush that ghosted him 10 years ago, and he used OSINT techniques to find her. He made contact with her via Instagram, and there were some cringy things in the blog post up to that point. But as soon as they finished their conversation on Instagram, he immediately attempted a password reset to get an email address. And then he continued trying to get stuff with the email address to the point of trying to reset the password for the email address so he could find out what kind of phone she used. So a lot of methods with that. And honestly, both of those, there are intelligence attributes to attempting the password reset stuff, but know that proper OSINT typically does not allow leaving a trace behind or any opportunity for detection. And that's a little bit more hands-on and active than what we typically deal with OSINT. At the end of the day, companies can still be exploited. So as an investigator, honestly, if I come across someone that I'm investigating and I don't find any social media presence, I get a lot more skeptical over that account. Certain things playing in, such as age, location, demographics, and things like that. But generally speaking, if you have one or two accounts under your name, I'm a lot less skeptical than if you don't have any. And as I stated before, why not have that autonomy and agency over what is posted with minimal effort? So here's links to the code for Decepticon. It is on GitHub. My username is Josephus, and it's Decepticon_bot. I'll share that link again later in the presentation as well. So the code itself is written in Python. I have two current versions. Only one is released at this time. One is leveraging TensorFlow and Keras. I'm using the NVIDIA port of TensorFlow version 2.2. The other version is written with PyTorch, but I'm not discussing it in this presentation because I still need to work out quite a few kinks with it. I use Pandas to organize the data in data frames. It's just an easier way for me to get the data put across. That, and honestly, the books that I was using to learn about automation, machine learning, and all that stuff using Python, they heavily advocated the use of Pandas. So I went along with it for that, and it kind of stuck. So within the code, Keras is used to implement a long short-term memory model, which is used to predict sequences of the text and then thus generate the text. So it's a long short-term memory model. In short, it's a type of recurrent neural network. More specifically, a neural network, not too far, a recurrent neural network is something that takes past decisions into mind, and that's going to influence the outcome with that. They can also remember previous things learned. So in order to do that, if the model is not actively running, you just have to save it to a specific file so that it can be reloaded the next time that the code runs and the model needs to execute. The reason these are very useful for things like text, speech, and images is that A recurrent neural network is not of a fixed vector size. And as we know, within natural speech, we don't have fixed vectors. For example, if I greet you, you may say, hello, good morning, good afternoon, how are you? Get out of my face. All of those things have different lengths, different characters, different lengths of words. So we can't say there's a fixed vector size for that. So a long short-term memory model in that specific vein seeks to learn order dependencies and do sequence prediction. So that's very important for generating text. And honestly, it doesn't even care what language the text is in. So you could, I've not tested this, but you could put it against text from any language, and it should be able to do that same order of dependencies and sequence prediction. So again, because of the prediction and dependency analysis, that makes LSTMs very lucrative for natural language processing. Another way, I've not fully researched this yet either, but another way you could accomplish this may be Markov chains. And me not having that solid math background, I'm still working on bringing up the rear in terms of taking some math classes that honestly are at the undergraduate level. I'm basically going to satisfy the requirements of an undergrad in math before I start 2 additional master's programs. So how does the code itself work? Basically, I use the Python Twitter package and the Twitter API to authenticate to Twitter and pull the tweets down for the user. By default, the tool only reads the particular user's tweets, but I have modified the code. If you look on the GitHub repo, it is actually under the SOC version where you can read anyone's tweets as long as the account tied to the API can view them. So if someone's blocked you or has a protected account and you can't see it, you can't read from their tweets, but anybody else, you can. So from there, we capture the text, the time of the tweet, and we measure lexical diversity. Basically, that's the ratio of the words used compared to the length of the text. Right now, it's not really that important, but in subsequent versions, I've got some revisions planned. I don't know when I'm going to get to them because I'm in the process of rewriting some training that I offer as the OSINT, but I have plans for assessing, say, time of day and other things, including also adding replies, retweets, and responding to messages. I also have plans to do a fork of it called Intercepticon that would actually identify other bot accounts. And then with lexical diversity, that could also be used to potentially identify if the tweet was written from someone that's a non-native speaker of a particular language, especially if they used, like, say, Google Translate to convert Russian to English or Mandarin Chinese to Spanish or something to that effect. From there, we tokenize it. I tokenize it by words. I've done limited testing with doing it by sentence, but it just didn't really jive at that time. So I need to do some more work with that. And then we add it to the corpus. Within machine learning and natural language processing, a corpus is basically a fancy word or not so fancy word for basically a bag of words. This is the input text. This is what we are using to train it with. From there, we get some standard stats like standard deviations and mean. And then we also calculate the post interval. Then we move into the generate module. That's where we establish our vector sizes and sequences, since we don't have a fixed size. And then we also measure the unique patterns in the corpus. We set up the files associated with the model in both JSON and H5. We define the model and the associated parameters, such as we are doing an LSTM model. It's going to be 160 bits. We are setting our sequence at 500, and we want to run for 7 epochs. From there, we go into the trainer module. That's going to create some pseudo-random seed to begin the tweet generation from. And then the next module will execute the model and assess the predictions. We work through a logic check And basically what that does is through my testing, if you look on my C_3P Joe account back in, I think, June and July, you'll see a bunch of odd tweets that are nothing but apostrophe comma combinations repetitively with like 2 or 3 words in them. That's because Decepticon, I was originally training Decepticon against that account, and it was just picking up on that, and it became problematic. So within the logic check, I filter out any links, any mentions, any hashtags, any known characters that I saw that would come across and make it a little bit more glaringly obvious that this wasn't written by a person. After all that's done, we tweet, and then after that, we wait. And that's going to be based on the post interval. Now we are coming up on the demonstration piece, so bear with me while I get that pulled up. Let me get it here. I just had it loaded previous, but no big deal. Let me swap screens with it. Can everyone see my video? So at this rate, we are just kicking off the code. So it's just running. It'll be just a moment. This is kind of a little bit of a long demo, but I'm going to talk through it. So there we see it's connected to the Twitter. It's retrieving the tweets. It's tokenizing it. At this point, we are able to see links. So these are all the Twitter links. We can look at mentions. So these are the accounts that were observed, mentioned. And then we start the in-depth analysis of the number of characters. So just doing some more stuff with that. We see here it has identified the TensorFlow device and the physical GPU, and it started the first epoch. This is just an interval of analysis, so this is going to take just a second. This entire process took about half an hour total. So there are parts of this where I applied a filter to make it go a lot faster. So here we've already started that first interval. As we can see here, it takes, in the case, it takes about 160 seconds. So right at 2.5 minutes to do this. So this is going to speed up. At this rate, this is just looking at the analysis of my Jetpack Nano platform that I'm running this on. Here we see the GPU is almost pegged out. And then as we go through everything here, we can see that this was as it was initializing the GPU device, it stopped, and then as the analysis started, it's kicked back up. We'll take a quick look at some CPU data. So nothing too exciting here. And then this is just looking at the memory. Notice I've got 50 gigs of swap. After you've ran the code for a few times and you're in waiting mode, you're going to need that because you're going to run out of RAM and you need that swap to be able to drop it over. So I have a 256 gig micro SD card that the operating system's running on, as well as about a 1 terabyte solid state drive that I've got an expansion board connecting with, but we'll look at that a little bit later. Here we have some control information. This is where we can control the fan, and then this is just some data here. So we go back here. We're going to see that this speeds up tremendously again. So I did an 8 times speed up on this. And then we're going to shift over. Notice the host name's George Jetson. So here we see that the GPU is about to drop off. And then what we will notice is once the GPU usage drops off tremendously, that's indicative of it moving from one epoch to another. There, it just dropped down pretty tremendously. And then as we shift back over, notice we've started a new epoch. So there that goes. I'm just going to move this along a bit. So number 3, number 4, number 5, number 6. Number 6 is almost done, so we'll go here. I'm going to get close to the end of number 7. Okay, so we should be good here, and then the timing will realign. Since I had that initial technical difficulty, just want to make sure. So here we see the random seed has been created, and we're initializing the process to create a tweet. So right here is what it tweeted. So if we can actually see this on the account, which I've already got the query set up, so I'll show you. Basically, this is just from one of the 6 accounts that it's following. This is something basically saying, for full disclosure, anti-vaxxers, vaccines cause autism. Me, y'all are idiots. Trump promises a COVID vaccine before the election. Me, Decepticon. How fitting. So we've got a sleep interval here. It's going to sleep for 76 seconds. That's for the purpose of demonstration. I actually altered the lines of code dealing with post interval. Normally, this would be the post interval minus between 0 and 480 seconds, just for a slight pseudo randomization. And we're going to see here in just a second, the process kicks right back off, tokenizes tweets, does everything, and then creating the model. And that's pretty much how the code runs. To actually look at the code, here's the requirements file. So this is everything that we need to install to get it to run. This is a file where we input our Twitter API keys. Obviously, I've not saved the file because I just cut my own keys out, but that's how we go about doing it. And I probably just closed. I did. You reopen. And because there's so many imports, I didn't want to eat up this many lines of code. So I just do an import, or I do one single import here and then import everything over here. So just a few things like random and JSON here. There's pandas, there's NumPy, TensorFlow, several cross things. So sequential, LSTM, so that we can get all of that. We have the tokenizer here as well. There's H5. I've got natural language toolkit, but I don't really use it right now, aside from the word tokenized thing. And then import the Twitter package and the Twitter API keys. So here's the code. We do the import, we set the encoding, and then we have all those definitions. But here at the bottom, we download stop words. That's not used in this current version because stop words would be things like and, the, or it would make it kind of awkward. So I've not implemented that part yet, but I still download it just for the sake of having it. We get the current directory. We check for the presence of a subdirectory called files. If not, we make it. If it exists, we continue. We set the stop words, but we don't use them again. There's the physical device. So we look for GPUs. If it works, great. If not, we continue. Here's the structure to connect to the API. So it's just giving the keys. We're setting tweet mode to extended so that we get all 280 characters. And if we don't set sleep on rate limit to true, we're going to limit ourselves to between 24 and 32 tweets, depending on how fast our system connects. So it takes a little bit longer, but we can pull down up to 200 tweets with the free API. We've set the model to sequential, and then results, that's just the get the user timeline with the API information. Next, we move to login. So we're going to go back all the way to the top. And from here, there's connected, retrieving tweets. When we set the global variable for data frame, make sure we move into the correct directory. Here are the users that the code as it's running right now are evaluating. I've got consent of all of these users. 4 of them are men, 2 are women. Some people live in the same area, some people don't. So there's a little bit of diversity of that. Obviously, it's not an accurate sample of the population, but I just wanted 6 accounts to work with. In this case, it's creating a files_soc.csv because this is kind of operating as if it's a SOC account. We create the data frame with the columns of tweets, times, lexical diversity, and the user. The version that just reads from your account does not have the user column. And then we move into tokenization. If we have the CSV file there, then basically what we're going to do is we're going to import it and then move on. Lexical diversity, there's the measurement. Going into tokenization, we have bag of hash, bag of mentions and links. So that's going to be hashtags, mentions, and links, just capturing all of them. Here we have a for loop for each user. We pull everything down. We're not focusing on retweets or replies right now. And then from there, we get the full text, we split that. I've got regular expressions to be able to put things into the appropriate bags. And then we move into the hopper. From here, we replicate a little bit of that effort. And then we have the tweet time so that we can put it into epoch time. So it's a linear time from January 1st, 1970. That allows us to measure the distance between tweets and pull that standard deviation. And then from there, we're going to go into the sorter, which is where we will actually iterate and tokenize. So here we're using the word tokenizer. We put everything into a single list, and then we tokenize it, put that into the bag of words. We write it to the CSV before we write everything that's in the data frame to the CSV before we move on. Collect our stats. So here we've got our lexical diversity. We get the mean and the standard deviation for lexical diversities as well as times. Post interval, that's nothing more than the standard deviation of time. So standard deviation in between the epoch times, that's how I arrive at post interval. Next, we do our frequency analysis, and then we go into generate. At this rate, we convert all the characters to numbers so that it fits into the LSTM correctly. From there, we define our X and Y, sequence length of 500. That's something that I toyed with in terms of shorter and longer numbers. 500 for this seems to be the sweet spot. So then we just append things to the XY plots. We determine the number of patterns based on the length of the X data. And then there we move into pre-model and training. So pre-modeling, this is just checking to see if we already have a model defined. So there's the H5 and the JSON. We can load. And then once we see that, we take the X and the Y, put it in 7 epochs, batch size of 8. That's just going to be the size of the stuff that's put in. If you have it too large, it will crash. If you have it too small, it'll take forever. The checkpoint, that's what we saw with all the epochs. We define the loss model as categorical cross entropy, and the optimizer's arm as prop. To be honest, I'm not 100% sure on that side. I looked at the various options and basically ran A/B testing to see what got the most accuracy. And then from there, we move into the actual modeling. So we define the 160-bit model, input shapes, return the sequences. We do a few iterations of that. The dropout, that's at 60%. I could have left this last value at 60%, but I put it at 40 just to see if anything would change. It did increase accuracy a little bit. And then from there, we compile. there's our checkpoints. That's what we see when it comes up. And then here's where it actually goes on to the GPU and what we actually see on the screen. From here, once it's done, we will convert all the numbers in the LSTM back to characters. And then that's where the random seed is created. From there, we will go through and basically do a for loop and just reassemble everything. That's where we're going to get our results in terms of what it's actually saying. Here's the logic check and the cleanup pattern. Notice all the stuff it's just removing. And then here's where it goes to sleep in the repeater. So there's the normal sleeping interval. Right now, I've got it sleeping on intervals of 40 to 80 seconds. So realistically, this could get 2, maybe 3 tweets out. And then it's just going to wait. At the end of that time, it wakes back up and it starts the process all over again. So that's pretty much the process there. So about the project itself, it started around December 2019. I ran into some hurdles, shiny objects, delays, etc. I had written some things in Python like WikiLeaker and some of the Recon NG module associated with it. But I am by no means a pretty Python coder. I am not even really an efficient one, to be honest. As I stated before, I'd been reading about it and I was trying to implement some things. I was working with Safe Escape on some stuff, and wrong key. So basically, I decided that this would be a good practical explanation. As usual, the project stalled around March, around COVID season. And then I was on a podcast of sorts, and someone was talking about the Jetson platform, and I was like, this might solve my problem. So I ported the code over, started playing with the tool. It worked really well. I was doing the original development in a virtual machine. I mean, I gave it 8 gigs of RAM and 3 cores. It was on a Radeon GPU on my Mac, and it wasn't efficient. Basically, each epoch took about 55 minutes as opposed to under 3 minutes. So this is the Jetson platform. On the left, we see the Jetson Nano, and then we have the USB 3.1 bridge to connect to the T300 board. That's the expansion board that allows me to run the solid state drive. On the right, that's just a regular Jetson Nano board. They're fairly inexpensive. I've got the T300 board in this particular case. I don't have the antennas or the camera on it, and I have about $250 wrapped up in it. But basically, it's got 128 CUDA core GPU, 4 gigs of RAM, and it's running a quad-core ARM processor. So nothing to scoff at, but it's by no means a supercomputer. I like it because it's external to my regular host, so I can continue to do other things on my computer while testing this, and I'm able to have that enhanced GPU as well. I've looked into hosting GPU processing in the cloud, and it is not cheap. So my lessons learned: data science is not a walk in the park, especially if you lack that heavy math background. Honestly, PyTorch is faster, but I've not been able to replicate the reliability. And if you've seen the tweets, that's to be lacking. So PyTorch is even worse. If you're testing this on your regular account, make sure you've tweeted frequently and something of substance as of late. All I had been tweeting had been announcements for my upcoming training. And my tweet interval was 12 minutes, or I'm sorry, 12 days. So what I ended up having to do to try to influence it, I broke several poems and songs, such as All-Star and Never Gonna Give You Up, as well as The Raven, Wasteland, and We Wear the Mask, into 280 character chunks and tweeted them so that I could influence that post interval and have more information. But that worked, and it created some interesting tweets. Another thing you should be cognizant of is if you're testing something like this on your regular account, people are probably going to start unfollowing you, and they will probably be a little bit angry with you. So I highly recommend testing it on an account that you don't use as heavily, like what I've done. Honestly, there was a lot of A/B testing and hypothesizing with this, and just know that around 200 tweets that only have 280 characters, that is a very small data set for an LSTM. For example, the book I was working through was using the book of Genesis as a corpus, as well as a few other books like Harry Potter and the Chamber of Secrets. Or actually, it was the Sorcerer's Stone, but nevertheless, something a lot larger than, possibility of 56,000 characters. That's pretty short. So limitations right now, I've only written the code to make use of the GPUs and CUDA cores. If you do it on a VM or a server, it's going to be very time consuming. Like I said, GPU in the cloud is very expensive, and the model is dependent upon what your account has posted. If you're setting this up for some violence and they have never posted, you're going to want to use the SOC version and have it pull from some other accounts. If the account was just wiped out, it's going to need to be the same thing, but you're going to need to get some things posted to have something to work off of.